What if there exists something in the universe so powerful that once you cross its boundary, there is no return, not even for light? For centuries, this was nothing more than a mathematical nightmare, a glitch in the equations of gravity. But in 1916, amidst the smoke and chaos of World War I, a German physicist named Karl Schwarzschild proved that this nightmare was a physical possibility. While stationed on the Russian front, he solved Einstein's complex equations and realized that if you crush enough matter into a small enough space, you create a permanent puncture in the fabric of the universe. He had found the blueprint for the ultimate mystery, the black hole. This is WonderDocs Studio, and we are stepping into the dark to witness the ultimate boundary of our universe. A black hole is not empty space. It is space pushed to its absolute breaking point. It is an object so dense that it warps the very geometry of the world around it. To understand this scale, imagine taking our entire sun, which is 1.3 million times the size of Earth, and squeezing it down until it fits inside a city. At its edge lies the event horizon, the final boundary. Think of it as a one-way door. Beyond this point, the speed required to escape the pull is higher than the speed of light, 186,282 miles per second. Since nothing in the universe can travel faster than light, once you cross this line, the concept of a way vanishes. Every path you take leads deeper into the dark. How does the universe build something so extreme? It begins with a 10 million year battle inside a massive star. A star lives because it is a nuclear furnace, pushing outward with the heat of billions of suns. Meanwhile, its own weight is pulling inward, trying to crush it. For eons, they are locked in a perfect stalemate. But when the star runs out of fuel, the outward push stops. In less than a second, gravity wins. The core collapses inward at 25% the speed of light, triggering a supernova explosion so bright it can outshine an entire galaxy of 100 billion stars. What remains is a core that never stops falling, collapsing until it becomes a singularity, a point of infinite density where the laws of physics simply break. Black holes aren't all the same. They exist in different scales across the cosmos. Stellar mass black holes. The common giants. They are roughly 10 to 20 times the mass of our sun. There could be 100 million of these drifting like invisible ghosts through our own Milky Way. Intermediate black holes. The mysterious middle children, ranging from hundreds to thousands of solar masses. They are incredibly rare and represent the missing link in how black holes grow. Supermassive black holes, the kings of the universe. These monsters contain millions or billions of suns. They don't just exist, they rule. Nearly every large galaxy, including our own, has a supermassive giant at its center. Our resident anchor, Sagittarius A star, weighs as much as 4 million suns. You might think these monsters are irrelevant to us, but without them, you wouldn't exist. If we replaced our sun with a black hole of the exact same mass, the Earth wouldn't be sucked in. We would continue to orbit in the same path, though we would freeze in total darkness. But on a larger scale, black holes are the cosmic architects. The supermassive black hole at the center of the Milky Way holds the galaxy together. Its gravity helped stir the gas and dust that eventually formed our sun and the Earth. We are effectively living in a house built by a black hole. They are not just destroyers, They are the anchors that allow galaxies to exist in the first place. The most haunting fact about black holes is their effect on time. According to Einstein, gravity warps time itself. If you were to orbit a black hole for just 1 hour and then return to Earth, you might find that 50 years have passed for your family. To a distant observer watching you fall in, you would appear to slow down and freeze at the event horizon, turning red and fading into a ghost. But from your perspective, time moves normally. Except as you look back, you would see the stars of the universe live and die in seconds. You would watch the entire future of the cosmos play out in fast forward before you are spaghettified, stretched into a stream of atoms just 1 cell wide. Even the most powerful things must end. Through a process called Hawking radiation, black holes slowly leak energy back into space. But this is the slowest clock in the universe. A large black hole could take 10 to the power of 100 years, a Google years, to finally evaporate. To put that in perspective, our universe is only 13.8 billion years old. Black holes will be the last things left in existence, lonely sentinels in a cold, dark cosmos, until they too vanish in a final, silent flash of light. They are the ultimate limit of human knowledge, a reminder that the most powerful forces shaping our life are the ones we cannot see. If the laws of physics break inside a black hole, could it be that they aren't just dead ends, but doorways to another universe entirely?